Thank you all for coming out tonight too. If you're tuning in on YouTube as well, I think this is going to be posted. My talk tonight is Secure AI Coding in Elixir, I Want to Believe. My name is Michael Lubas. I am the founder of Praxial.io. That's the first and only security company with full Elixir support, which sounds unusual considering how many security companies are out there right now. There's hundreds, probably even more than hundreds, but none of them have good Elixir support for some reason. It's an emerging technology. I've dealt with this problem myself. And a few years ago, I was in this unique position to do this company because I'm also an Elixir developer, open source contributor. I'm a member of the Erlang Ecosystem Foundation, the security working group. Prior to learning Elixir, I have a background in web application security testing. I was working for consulting firms, doing work for some of the big banks here in New York. I've worked at startups, that sort of professional background before starting the company. And I've really found the Elixir community to be fantastic. And it's very cool to be able to talk to people, engage with the community at events like this tonight, talk about security and learn what people are working on. So, topic for tonight, when your Elixir application gets hacked. Kind of a scary thought that's in the back of everyone's mind. You hear about cyber attacks in the news pretty much constantly. For example, I believe Jaguar Land Rover is currently not producing cars right now because of a cyber attack. So things have gotten very bad where companies are completely dependent on their information systems. And if you're an Elixir developer, your work is very much tied into that. And at the same time, there's a lot of information out there on cybersecurity. And as a developer, it can be very overwhelming. And there's a few reasons for that. I think a big one is that a lot of cybersecurity information on the internet is just very bad. It's sort of broadly targeted. It's not helpful for developers. So my goal for tonight is to give you some context for what's going on in cybersecurity and how is that relevant for you and your work. So a bit of context. What does it mean to be hacked? Your company has been hacked. Okay, well, what the heck does that mean? In 2017, there's this company here in the United States called Equifax, and they had a series of Apache Struts apps. So Ruby has Ruby on Rails, Elixir has Phoenix, Java has a few web frameworks, Apache Struts is one of them. And there was this vulnerability in the actual web framework, Apache Struts. Equifax didn't have an inventory. They didn't know where all of their Apache Struts apps were. They couldn't patch them. This exploit became public for the framework, and they got hacked very badly to the point of leaking, I think it was over 100 million social security numbers, which is the private identifier in the United States. I believe some Canadian citizens were affected by the breach as well. The big point was that after everything was said and done, the settlement costs alone were between 425 million and 700 million, depending on the news source and the reporting. That's an insanely large amount of money, I think. So to put it in context, Equifax's 2017 revenue was $3.4 billion. So that's about 12 to 20% of all of the revenue before business expenses. So that's not even profit. This is just revenue for that year was dealing with this cyber attack. And tonight's talk is going to be very technical. I'm going to go into detail about Elixir serialization in terms. The business people at your job have no idea what any of that means. It's a completely different language. They understand this, though. If you take these numbers to any business person or C-suite executive, it will register with them that this is a risk. So when you go to your job and you say, hey, for our Elixir applications, I'm concerned about security, we should be doing this, this, and that. This is a very good way to frame it. not so much in technical terms. Even if the technical terms are correct and you're correct to frame it that way, doesn't really resonate with people. Typically, these are the numbers that do that. Also worth pointing out that this 2017 was a data breach. So the hackers broke in via the Struts app. They got remote code execution, which grants you the equivalent of production SSH access to the server. Once you're in the server, you have the application level permissions. Oh, you can just read the database. You can pivot through the network. You can do all sorts of bad things. The end result of this incident was the data breach in 2017. And it gets much worse as the years go on and cybersecurity changes. Because now in 2025, you have to deal with ransomware. This is the estimated ransomware payment totals from Chainalysis, a cryptocurrency sort of tracking law enforcement analysis company. And their estimate is basically it's been about 1 billion per year since 2020. I don't even know if these numbers are necessarily correct. I think it's probably a little higher because it's so profitable. I'm assuming everyone here knows what ransomware is, where essentially one day your business operations stop working and you go to log in and your production database has been encrypted. And the bad guy says, hey, you want all your production data back? You want that to keep working? Send me $50 million in Bitcoin. And some companies do that because it's cheaper than eating the downtime costs. And that Equifax example I gave earlier where they broke in and just stole the data, today they would probably encrypt it and delete all the backups and say, oh, you want your encrypted data back? Okay, give us, $100 million because it cost them 700 million at the end. 100's lower than 700. That's the scale of what we're dealing with. Since every business is connected to the internet, this is not going away. This is just going to get worse. So I've not talked about Elixir at all yet. I wanted to just give this background because we're going to be talking about exploits and get very into the technical weeds, but big picture, if your Elixir application that's exposed to the public internet is not secure, this is what you're facing down now. It's not even just a data breach. Ransomware has definitely been the big innovation in cybersecurity in the past 10, 20 years, and it's very dangerous for businesses. When you think about it, though, it's really it's new, but it hasn't changed really because ransoming ships at sea, that's been going on for thousands of years, pre-biblical times. We've just changed from naval shipping to mostly information systems these days. So I don't think it's going away. I think that extortion, that sort of adversarial attack, that's just inherent. That's never going away. And as developers, we just have to deal with it and make sure that the applications that we're deploying into production are secure. Okay. Finally, the Elixir part. So we're going to talk about an Elixir application being hacked. I want to present a simplified model. I know the Phoenix application you probably use at your business is more complex. It probably has a lot more topology than this, but I think this is really good for just a basic example. Just imagine a Phoenix application that does sort of business document process management, where you upload files and it's sort of a Jira-like or I would say SharePoint or Jira, just project management software. I feel like most people on the call can just picture that and how they would code it. And all of the customer data that goes into a Postgres database that has the passwords, that has user information. If that Postgres database goes down, nobody can use the software as a service. The business stops making money. For this example, all this is deployed on EC2 server and AWS. This is on RDS, not exposed to the public internet. The customers connect through HTTPS, and that's how they interface, from their mobile application or their desktop. And then if you, as an admin, need to SSH in and do IEX and debug something, you're probably going over port 22. That basically grants you full access. That would probably be monitored very heavily. There's probably like a 2FA process in place, but this is just what we're talking about in terms of like a Phoenix application that's deployed. And this is what we're going to be talking about with coding today with AI and what could get hacked. So you're a bad guy, kind of similar to that Equifax example from earlier. If there is a vulnerability either in the Phoenix library or dependencies or in the code that you're writing, and you deploy that publicly, and a bad guy finds it, he can get the equivalent of, admin access, full prod SSH access. And then if you're hacking it through the Elixir application, I'll talk about the remote code execution and how that works. The Elixir application has to have full database permission. So if you manage to hack this, you're in the production database. The security of your Elixir and Phoenix code is extremely important. And with the rise of these sort of AI-generated coding tools, or I would say even more importantly, perhaps the pressure from management to use AI to increase productivity, there are some very real, very, very big security concerns. So this was a headline from the Register about AI coding assistants and their security problems. AI is fixing the typos, but creating the time bombs. The firm found that AI-assisted developers produced 3 to 4 times more code than their unassisted peers, but also generated 10 times more security issues. And to sort of be very honest with this study, I think this was conducted by a software security firm. So naturally, the attack line you could use against this was, well, yeah, of course, an AI or a security firm will publish something like this. And you can kind of quibble about the methodology and say, oh, well, they did this, but it's not quite realistic. And I know you can kind of get into the weeds for that. And studies are not the gospel truth of anything. They're usually modeled in these very simplistic ways. I'm very aware of that argument. At the same time, the reason I put this in my presentation is because I think that this is directionally true. And I think everybody knows that this is true. Where even, you can debate the studies, you can debate the methodology. I would say the vast majority, let's say 99% of developers would say, yeah, if this code was generated by AI, I don't think it's secure. We want to get a pen test to look at it. We want someone to review it. There's risk. Probably the best real world example of this would be Coinbase recently fired people for not using the AI coding tools. And then in the X thread under it, where the CEO posted the chart of how much code was AI generated, he said, we are aware that there is risk here and we have a framework to mitigate that risk. So even the most pro AI people in the entire industry sort of will acknowledge that there are security problems here. Obviously, the anti-AI people will just say, yeah, this is a dumpster fire disaster. They'll be very negative. But even the pro-AI people, this is true. So don't need to harp on this too long. But I think everybody sort of agrees with this. It's a very hot topic right now. So let's get into some Elixir code. You are an Elixir developer, and very simply, you have a tuple. So Atom ABC, integer 1, 2, 3, 4, string hello. And this does not cleanly encode to a JSON, like a JSON list that you can send over the wire. And the reason that's relevant is, imagine you're given the task, hey, we have this Elixir term on one computer, and I want to send it to a different computer. And I want to be able to get that exact same Elixir list, tuple on the computer. This is a very simplified example, but I'm sure everyone on this call has dealt with a very deeply nested map, tuple, list, just very nested data structure. and it wasn't going to cleanly serialize to JSON. Maybe you had to write a JSON serializer. I remember one job I had where that was a huge amount of code. But you say, you know what, that's a ton of work. I'm going to ask my LLM. So hello, ChatGPT or Claude. I have an Elixir Phoenix application. I have the following very complex Elixir term. I know this is the simplified, but doesn't map clearly into JSON. I want to take this term, send it to another computer, also running Elixir. Okay. The response from the LLM, which I think is actually very impressive, is that it will mirror what a human would tell you, which it will say use Erlang term to binary. And then on the other side, deserialize that binary with Erlang binary to term. And it will even highlight that this can be insecure if you decode binaries from untrusted sources. So to mitigate that security problem, you pass safe to binary to term. Okay, that sounds pretty good. And let's say you prompt it again. You say, I am concerned about security. Could you show me how to do this safely? And it will tell you the wrong answer, which is the previous one where it says put safe at the end. The interesting point is that this is the same mistake a human would make. So the hype around LLMs is really that they generalize very well. And this is impressive. This is pretty impressive, even though it's wrong and it's a security nightmare. I do think it is impressive because it's wrong in the way a human would be wrong, or this is a vulnerability that a human would introduce. So I wrote a guide to Soblo findings. Soblo is the static analysis tool for Elixir security. So you take your Elixir Phoenix code, you put it into Soblo, and then Soblo outputs the potential vulnerabilities. And in the guide I wrote, I said, don't do Erlang binary to term. The safe one is actually non-executable binary to term because that safe list only prevents the creation of new atoms, which is a denial of service, which is bad, but the executable binary to term is really, really bad because if a bad guy can send a payload that gets deserialized and there's a function in there, then that's the vulnerability. That's how you get remote code execution and that really bad Equifax breach from earlier. Okay. So if you prompt it with this information, though, it will learn. It'll say the modern safe fix for Soblo warnings. Instead of using safe, which is not bulletproof, use plug crypto's non-executable binary to term. So you can also teach the LLM, say, yeah, you're absolutely right. But typically it just, they're sort of malleable. Everyone's probably run into this. So the bigger point I want to make is that LLMs don't magically spit out insecure code in my experience. I would say that the vulnerabilities typically come from what kind of feature are you adding? So that serialization one from earlier, maybe you want people to be able to send a function to your application for some business reason. And maybe the LLM will help you accomplish that goal. The problem is that goal is a security nightmare. Other examples would be, imagine a Phoenix application where you want to take a URL from a user and display the dig DNS records. So you run the dig command and it gives you the DNS output. If you gave that task to an experienced developer, they would code command injection in. Or this is something I see all the time on penetration tests, where an application will have the ability to take some user input, think of like a comment form on a ticketing system, and you can bold an underlying text. And if you're a security person, your alarm bells immediately go off for a very common vulnerability, cross-site scripting, that is just directly follows from that feature. Consider another problem where you have to code a SQL query and it requires some Postgres or other database feature that isn't supported by Ecto. Naturally, that will lead to SQL injection if you don't do it correctly. which is often as bad as remote code execution, especially if in some cases you can get remote code execution on the Postgres server itself, or just leak all of the data out of the server. That can also happen. Or consider a controller in a Phoenix application that takes user-supplied input and reads a file that's stored on disk on the server, and that's vulnerable to path traversal. So now you can read any file on the disk, such as etc password or the SSH hosts file. You could get the private key. The key point that I just want to make here, why I'm kind of harping on this, is yes, large language models have their security problems, where you'll really run into this security risk. It's dependent on what you need to do when you're coding your application, the sort of business functionality. And in my experience, LLMs, they're not really good at assessing risk or guiding you, because they're ultimately giving a probabilistic result. So if you say, for example, I'm worried about this feature, what should I do? Well, you saw it earlier. It said that the safe option, you could kind of see how, oh yeah, the safe list, that makes probabilistic sense. You know, the embeddings or whatever, or the weights, it would weight the word safe. So it's got to be safe. It's not going to weight non-executable binary to term as heavily unless you tell it to, and you have that experience. The other big problem is that there's not really secure code out there. People will sometimes do this comparison and say, oh yeah, well now all the code on the internet is LLM generated and none of it's secure. Well, the code before LLMs was also not secure. There's no major software project out there with any significant user base that has been 100% free of vulnerabilities. And that is just true. You know, people sometimes idolize certain programmers, but they think, oh, this is the smartest programmer who ever lived, could never write a vulnerability. But any major security or any major software project has security problems. And then all of the LLMs of today were trained on that code. So it's funny because if you have to implement a business feature, in a lot of cases, the most likely output is just not secure code. And I know there's this kind of maybe AI lab cope that, oh, well, the models are just going to get so much better, they're only going to write secure code. Well, the problem is that people also want to code business features that aren't safe, and that's not going away. I'll get into that a little bit more later in the talk. I would say the good news is, since you know the AI will probably be writing unsafe code, you can prompt it with Elixir specific security information. So this is the new GitHub repo for Soblo. As a tangent, Soblo was created by Griffin. He used to work for a company called NCC Group, which is a pen testing firm. They held the Soblo repo for a while. After Griffin left NCC, they didn't really do anything. Holden is the new owner, and he ported everything over to Soblo. So you won't notice this as a Soblo user, but this is actually the new repo. NCC Group, I think, actually banned him, or didn't ban him, but he couldn't access the GitHub repo, even though he was the only one maintaining it. Like, nobody at NCC Group cared. So that's why it's over here now. And I've got some pull requests in there now. I'm working with Holden, and there's some big updates to Soblo coming. That's a pretty common question I get about Paraxial.io is, you know, do you have a Soblo ++ project? And I don't think that's a good idea, just for the open source community. Paraxial.io is a different, I won't get into the details of it right now, but for Soblo, any updates or changes or improvements, I just want those to be open source because I think that benefits the community very strongly. So I also wrote the Soblo findings guide. That can definitely fit in your context window. I also wrote the official Phoenix security documentations. That went out in Phoenix 1.8. It has that example from binary to term, which is very, very important. If your application is vulnerable to that, that's a security disaster waiting to happen. So I would recommend, if you have a AI coding workflow, very straightforward, just, well, use Soblo. but also prompt your LLM with this information. Say, hey, read these documents and consider that when you're generating the Elixir and Phoenix code. And this is another point I want to make, where the security industry very much wants a generic solution. I shouldn't say security. Security company investors want a generic solution. The sort of perfect security code security tool would kind of magically work with all programming language perfectly. And that's what we saw with the AI models, where the AI models generalized very well. I don't really see that happening right now, at least, or even in the next year or so, with the web application frameworks. And what I mean by that is, if your business is extraordinarily reliant on WordPress, you don't buy security from one of the big AppSec vendors. You go to the WordPress specific security company. If your business is extraordinarily dependent on Elixir and Phoenix for operations, and the security of that is really important, Praxis.io, pretty much the only game in town. And I don't see that going away, because this generic, when the big companies are going, we're going to solve all of the cybersecurity problems, in practice, that means we're just going to solve the biggest one. So it's like Python, NPM, and Java, which is what all the Fortune 500 or the Fortune 100 pay the most money for. That's why I'm very happy to be doing this work, which is Elixir and Phoenix specific, because none of the security vendors out there know about binary to term. They don't know about Ecto or the kind of Elixir specific problems. Where they do get specific, it's in the kind of big enterprisey problems, Kubernetes, things like that. So this is an experiment that I ran with Claude Code, and this is with Mix Paraxial Scan, where it's not actually using AI itself, but I'm sort of using the feedback from Paraxial, which is running Soblo. It's running a scan of the dependencies, outputting those findings, feeding that back into Claude Code, and then helping to fix it. And the point that I want to make here is that you can use both. Soblo is a good example of a stack analysis tool, where it's very cheap to run that in a pipeline. It's less than a penny per run. But if you're using, let's say, a token consuming LLM, where you say, I'm going to use Claude Code to do a security review on every single new PR. Well, let me explain. You can, but I don't think it's the solution that it really makes sense. Maybe it does now, but it won't in the future. So here's what it all comes down to. The majority of businesses that are using AI to write code, they want more features for less money. That's the ideal. Imagine you're paying $10 million for your developer payroll staffing, and you get a certain amount of features out, and then those translate to a certain amount of new revenue. The reason I believe there's so much hype around AI and coding right now is because businesses had this moment where they thought they could replace all the developers with AI. Hasn't happened. Doesn't seem like it's going to happen. What I think we are seeing now is this tremendous pressure for developers to ship lines of code and for their productivity to increase with AI. Investors want it, the executives want it, your manager probably wants it. Well, maybe not everyone on this call, but speaking very broadly, you can see how these incentives would align. And pushing code that you didn't think about at all, didn't read, well, I'll put it this way. Imagine sending an email on a very important project or for a very important deal, and an AI writes it for you, and you don't read it, and you send it. It's insane. That is what is also happening right now, where people push code into production without security checks or without even reading it. But that's definitely happening because all of the incentives are there, and we'll probably see a really bad breach somebody told me that the T app breach, which was a site to, you could dox people on it or something. I don't know exactly how it worked, but they said that the app was vibe coded, and the guy didn't know how to secure the bucket in Firebase or something, and everyone's IDs got leaked. It seemed very, very bad. But the point that story really illustrates is that I'm sure that company had $0 budgeted for security, or extraordinarily less budgeted for security than new features, because every business, just by the nature of how a business works, they want new features more than security. There will be more money allocated and more demand for features to be shipped than for security. So I think that if you take an experienced Elixir developer, which we sort of live in this bubble maybe where everyone on this call is a very experienced programmer, you know about this stuff and the risks, you might find that when you use AI tools that it actually seems very secure, because you have the judgment to recognize risks, to run security tooling on the code that you're writing before you put it into production. You know, it's kind of augmenting the fact that you're probably a very skilled developer already. Okay, well, we also have a generation of developers that probably do things in a very different way, and they're just incentivized to ship lines of code. And, you know, we're going to see the inevitable security outcome of that. So in summary, AI coding, it's very new. There are very big security problems and questions that are happening. At the same time, I would personally feel very comfortable, you know, putting AI LLM in the hands of an experienced developer, letting them use it to enhance their productivity. You know, Jose Valim, Chris McCord, two people I respect tremendously, said that they found AI coding tools beneficial in their workflows, and I believe them. And I believe that they're not shipping, you know, the code that they write is going to be remarkably high quality and secure. At the same time, they represent a very small fraction of developers. A lot of people are just going to be pushing whatever they can get out the door. So in conclusion, the risk is real, but there's mitigation in place. And at the end of the day, you're not really going to be able to avoid the labor of thinking. There's a very famous quote. Thomas Edison had it on his desk, I believe, that said, man will go through any lengths to avoid the labor of thinking. You know, people think that AI means we're never going to have to think again. Doesn't seem that way. Coding is always going to require some level of mental load, maybe not the way it was 10 or 20 years ago, but you're going to have to think things through if you don't want to get hacked and have this sort of catastrophic data breach or ransomware incident. That is just the way things are going to be. And I would say that they're going to remain that way for the foreseeable future, no matter how much better the models get. Okay. Thank you all for listening to me ramble tonight. My name is Michael Lubas. You can find me on LinkedIn. That's where I'm pretty active. I'm also in the Elixir and the Elixir Discord and the Elixir Slack. Here are the Praxial.io socials as well if you want to follow my work. I have a YouTube channel with Praxial. I publish sometimes on there, but I believe this talk is going up on the Elixir Montreal. So thank you all. I'm going to stop and we can go to a Q&A now.